Hello and welcome back to another episode of Hedgehog Makes. My name is Austin, aka Zombie Hedgehog, and I've made a little bit of progress on the Rainbow Doom since I recorded my last video. Previously, I showed just the one CNC part of the gantry, and as I expected, it was very simple to continue the rest of the gantry. You just follow the instructions and get it all assembled. Now, the one note that I'm going to reiterate is on the back of the gantry. If you watched my previous video, which if you haven't, I would watch that one first. But this plate right here, so these two plates, the belt tensioner here will get stuck if these are screwed in tight. So I would recommend keeping these a little bit loose. So keep every single one of these screws just very mildly loose, okay? And that will allow you to actually tension these belts. And then once everything's tensioned, you can retighten this top plate, and that actually will help hold the tensioner in place too as a side effect. But that's what we've done off stream, is completed the majority of the gantry. So we have all four motors installed. The front motors, I've run the belts, I fit the wires exit this way against the frame, and they route down this channel down here. And there's not really much to it. I just followed the main instructions. Something that I hinted at last time, but didn't really show the process of, are these idlers. I didn't really know how these were going to work out, so I went ahead and installed them. These are pretty cool. So this is that Heart K mod that I was talking about previously. They are called live idlers. And as opposed to a traditional Voron build, this whole thing right here would just be an idler. Whereas now it is a pulley. So I had to do things a little bit probably different than what's recommended, or the proper procedure. And I can show you that a little bit closer here. So, a couple things. I am not using any of the 0.5 millimeter shims that are listed on the BOM for this mod. I'll have a link for that in the description. So the idler does have some play up and down, some potential play. Ideally, I would go and order one of those shims, or I could print one. I could definitely print one out of ABS if I wanted to. But I think it's gonna be fine. I'm not too worried about some slight movement up and down. I don't think that'll affect too much, honestly. And two, I didn't really feel like grinding any of these pulley, pulley grub screws. So as you can see, I have no grub screws in the pulley here. So this is just kind of free sitting in there. And because that shaft is actually pretty snug, there's almost no play on that pulley. So I think it's gonna be fine. We're gonna try it out as is. And if there is an issue, if we do notice any type of problem, then we can fix it. But I think this will work out pretty good here. It seems like it flows pretty good. Everything seems like it works fairly good. Moving the gantry is actually kind of interesting because we have 4 motors engaged right now. And I have not tuned the all-wheel drive pulley locations yet either. There is an additional step that you'll have to do once you get the whole printer built. There is a guide somewhere on how to align the front 2 all-wheel drive motors, essentially by engaging the motor, and the motor will kind of lock into its closest position, right? Because it's a stepper motor. It runs in steps. So 1, 2, 3, 4, 5, 6. It has positional steps. That's how a 3D printer works. And in order to sync up 2 motors, we'll have to loosen the grub screws on one of the pulleys, engage all the motors, and then retighten it. I believe that's essentially the process. So we should be good to do that. Another side note is on these pulleys. I think I had a question in one of the previous streams about a smooth shaft. I thought these motors actually had a smooth shaft, but no, these are D shaft cut. What that means is that on part of the pulley right here, it is smooth. So for these front idlers, because we'll need to fine tune where the pulley location is, so we're gonna loosen up this pulley here, loosen up this grub screw here, and then once we have the motor locked in, we're gonna retighten them. Because we need that fine positioning, we actually can't use this flat shaft. So theoretically, what we'll want to do is get the shaft pointed kind of away, away from here. And then we'll want to loosen up these grub screws and kind of have the grub screws on the opposite side of the D shaft. So we're screwing onto the smooth side of the shaft, just like so. Get them nice and snug, and that should be fine for our setup there. So I will test out these XY joints. As I said, I'm actually kind of excited to try them out, and eventually I might look into another option and maybe get these a CNC'd version of the live idler mod if it's any good, which there are options. But for now, I am sticking with the LDO all-wheel drive CNC kit. And I kind of like how it has a splash of ABS here too. It's not just all CNC, it's kind of boring. We are using beautiful, beautiful Polymaker ASA blue, Galaxy blue, and ABS Galaxy dark gray. And those combined just look gorgeous. So that's gonna be our main printed part color scheme for this build. Additionally, I went and completed the main part of the Z-axis. We have the linear rails installed and lubed on all three sides. The motors are installed with the lead screws, and everything seems to be working out pretty good with those so far. Another note, and I'll have to link which ones I found, but these specific mounts right here for the motor, number one, these are for the inverted electronics mod, which allow us to insert and remove a panel and remove the whole panel from the bottom of this printer, exposing all of the electronics, right? We're gonna have electronics sitting inside of the bottom of the printer. Very, very easy to maintain, much easier than a 2.4, which is why, another reason why this printer's just easier than a 2.4. But this specific version has a cutout, and I don't know how well I can show that, but it has a cutout over there. Oop, I had it. Right there. So this cable for all-wheel drive goes down and actually around right here on the back. And that'll allow the panel, so this will go down like this, the panel will be able to sit in where it's supposed to go, and these wires are able to be routed. Then we can plug them straight into our control board. So that's how I have those routed, and that is probably the only thing that is different than a stock Trident build. For the most part, this is just a Trident. There's not much different. And in this episode, I think we're gonna go and try to install at least a part of the bed. So we'll start that in a few minutes here. But additionally, before we begin that, one of the last things that I did off of stream, which by the way, these are all being live streamed to Twitch. Hello chat. We are streaming live. So if you're watching this on YouTube, you're not watching it live. Why aren't you watching it live? Probably because it's too late at night. That's okay. If you can, please tune into these live streams and ask your questions. We talk about a lot more than just this on stream. We go over Q&A sessions for just general 3D printing, as well as extra building of stuff like this, stuff that I just don't record for YouTube. And yes, we talk about tuna salad. Thank you, Peslas. Finally, the skirts. The skirts are nothing like I've ever used on a Voron printer. I think I briefly showed off the feet last time, but these feet and the whole skirts are custom to this build. They are designed by Hart K. I have a full CAD model in the description. But these feet right here, the blue part prints separate to the gray pieces, and you just snap them in or use a little bit of persuasion with a hammer. And then these skirts right here are really, really cool. I haven't seen anything like them before. So the main part prints like this, and it's a basic color swap. So no supports for anything, and you color swap. The model has different objects for each color. So you import this into your slicer, change the parts to whatever color you want, or you can print it as a single color. Doesn't really matter. Just looks nicer with that color swap. And there you go. And like I said, these gray parts printed or go in separately. So those kind of snap in. On the bottom here, there are some heat insert parts for this gray strip. It's just purely aesthetic, which looks really awesome. And then on the back right here, there's gonna be a mount. So this will go in like that. Just like that. And with the printer upside down, we're actually screwing into this extrusion here. So the base extrusion for our, our standard Trident size build. And technically, this means that this extrusion right here is not attached to the skirt. So for whatever reason you didn't have this part, you could still use this skirt. Or if you had like a printed version of this, something or another, that is just an interesting design. So thanks to Hart K for making these custom skirts. I'm interested in using them. And really interesting, on the top skirt, which yes, we do have a top, they'll kind of look like that right there. Those middle sections right here are actually going to be buttons, or potential buttons, that you can insert a switch and hook it up to your control board and have a customizable button for a macro, for anything. If you want to load and unload filament using buttons, you could do that. If you want to adjust your LEDs, you could do that as well. There's a lot of options, and I'm very excited to try that out as we get this thing progressing. I've also printed off our tool head. I've decided to start this build. We will try the LDO Jabberwocky tool head. So I printed off all the parts here. And once again, the blue parts are a Galaxy blue. This is a ASA for the Galaxy blue. These are Polymaker filaments here. Highly recommended for printed parts. I've used many ABS and ASA printed parts from Polymaker, and they've all been fantastic. And I love how the Galaxy blue looks. It's always gorgeous. And of course, we have to go with Galaxy for our accent part 2. So I picked a Galaxy dark gray. This is an ABS, but ASA, ABS, they work perfectly fine together. They use the same settings for the most part. At least mine do. I run them all kind of hot, I think 265, and they print beautifully. This part right here was printed on the Bamboo H2S. Just perfect, flawless. I could not ask for anything any better. Very, very happy how these parts came out, even though you won't really see the sides. You can see parts of the tool head. So it's good to have a high quality printer for printing your ABS parts. And it seems like the chamber heater in the H2S does make a difference. So good job, Bamboo, for that. And then one more kind of unforeseen addition that I'll have to get for this printer: panels. I was expecting to use these stock panels for the sides and the back, and I'd have to purchase the bottom panel the top panel in the front door. So it turns out the stock side panels are a little bit too big to slide in as expected. And it was confirmed that you will either have to get custom panels or cut down these existing panels for these sides, if that's what you want to do. So, I will actually be ordering ACM panels for my sides. And if you're unaware, ACM, generally those panels have a nice matte finish on them compared to the glossiness of an acrylic or a PC panel. So I'm very excited to get those custom ordered, and I'll put those on the side, the back, the top, the very bottom, and I'll probably, just because I want consistency, I'll probably order a deck plate too, and that looks like this right here. I have the protective film on there because I haven't used it yet, but this right here will go in on the deck. And since that'll actually be one of the most visible panels, I'll probably have that made in ACM. So that'll be cool. And I am considering, and by the time I publish this video, I might have ordered it already, but I'm considering ordering a tempered glass front panel. I could do that, right? We're encasing it in extrusions. If you take a look at the CAD model right here, the front panel right here has a custom door, right? So if I isolate this this door, well, that's not what I wanted. Can I isolate? Oh, okay, the door. This right here, that is a frame that will swing out and encase this panel. Kind of like the fridge door mod. We're doing that for all the panels, so the panels will sit inside of the printer. So I'm thinking, why can't this be tempered glass? Why not? So not only is it going to be protected by these side extrusions, it also has that gasketing material that we'll be using, again, from the fridge door mod. Also, the box turtle uses them for the enclosure. So why not? I'll try it out. So I'll be looking at a couple different sources for those, and I will definitely let you know in that video, in one of the update videos, what I end up going with. And the best part about this printer is that nothing is set in stone. I'm kind of building it as I go. So as I progress, I've been making a couple of changes or deciding on doing different things. And for example, the bottom panel here, this is just an example of how Hart K laid out his bottom panel. I might decide that either I might want 0 holes, or I might actually add in a fan mount, right? I can blow in air with a 120 millimeter PC fan. Why not? So there's options for different cooling setups. I didn't realize that there is no side fan intake like a traditional Voron. So we're probably going to want to either exhaust hot air out the bottom or suck in air from the bottom. And typically for stuff like this, I'd rather push air out the bottom just in case there's, not much flow underneath. So we'll see. We'll see. There's options. Many, many, many options for this. And if you want to suggest something specific, put it down in the comments here. These update videos are more or less updates on what my progress is of the video. But let's do a little bit of building, because I want to show off the bed for this printer. One of the coolest things about building an LDO printer is that they have a bed that is already done for you. Everything's all done. And it's just so nice to have a bed that has everything. So this is the part where I'm at in the manual, minus the tool head. I'm actually using a random a random backplate from something else that is temporarily holding the belt in place, but we will be replacing that back X carriage, as they call it, with one of these. This is from the Jabberwocky. So that's the main difference, is that I'll be swapping over to that. And I'm not sure if I will be recording the Jabberwocky build on stream or record it on video. I guess you'll find out in a future episode, but if not, then I'll explain the process I went through with that. It was a very easy build. I've already built one before on stream, and it was actually quite enjoyable. So that's, again, LDO Jabberwocky. You can find that at West 3D. So the print bed. This is what it typically is. It's a metal plate. And there's a magnetic sheet you have to apply. Assuming you're going with a traditional plate, you would put on a big magnetic sheet that you have to clean, you have to install. Kind of fun, but kind of a pain. And then you have to apply the heater. Depending on which heater you use, you also have to apply that. And typically you want to let it set with some weight on it just to make sure the adhesive is adhered. But I don't like doing that. So I'll show off what LDO includes in their kits. And you also have to include your thermal fuse. So let's take a look at the LDO bed system. Again, one of the reasons why you'd want to pick LDO over another brand is that they come with this. So in this box right here, which is very neatly and perfectly cut. If you've ever opened up an LDO box, you'll know that everything is overly packaged. This could not get any better, honestly. But we're going to carefully take out the bed and then put this all aside. So right here, we have everything. We even have the PEI sheet pre-installed. So the PEI sheet I will take off just so we don't damage it. LDO typically includes a PEI sheet with a textured and then smooth finish on the back. So depending on what you want your parts to look like, you'll have some options. You also get a nice magnet. I find that their magnets are very high quality. They're pre-applied. The holes are already cut. You don't have to cut any holes to access the through holes for mounting. And on the bottom, this is what's amazing. You already have a heater applied. And not just that, but this is a 600 watt heater for a 300 millimeter bed. The heater is also bolted on with screws. So even if it loses adhesion, full adhesion, it'll still be mounted with screws. That's a very good safety feature. This is a custom cut heater with cutouts for all of the specific mounting points. This is actually a compatible with a 2.4 as well. It has the mounting for that. It's a dual bed. But we have everything we need. We also have the thermal fuse pre-installed. Very important. You don't want to skip on that. All this does is, if this bed, for whatever reason, stays heated, 100% power infinitely, this thermal fuse will trip at 125 degrees Celsius. So if this bed gets over 125 C, which theoretically, I think this can handle up to 130. So you want to protect it by limiting it to 125. This thermal fuse will trip. You'll have to replace the thermal fuse and your bed will be saved and you won't start a house fire, which is always good. Also, everything is pre-wired. We have our thermistor already in there. So everything is done for you. It's really easy compared to maybe having to do it all yourself, which I've done many times. And I'm kind of, I'm not over it, but let's just say I do prefer what LDO offers here. So in the manual, we have that print bed, which is already pre-assembled for you. We don't have to worry about, I don't know if they have a ground we have to connect. We'll see if that's necessary. Usually it is. I will check the wiring, see if we have one. We don't have to do anything with the ZN stop because we are using a beacon or a cartographer. I have not decided yet. Theoretically, I would probably want to go with the beacon, but if the beacon shows up after I install the toolhead, then I'll probably install a cartographer. They both work very well in my experience. So no Xeon stop needed. But we do have this. Now LDO, I don't know if they have a specific Wago mount, but they do include some printed parts. I didn't realize this. So the Rev D kits now include printed parts for LDO specific things. Pretty cool. So we have some, these are mounts for the Leviathan board. But what I'm looking for is this. So I think, is this our bed mount? It might be. Let me actually take a look at the LDO guide. I'll have to pull that up here and see. LDO Trident documentation. And let's see if it mentions the bed. So we're gonna go to Voron Trident Kit. This is the LDO documentation page, docs.ldomotors.com, and we have some build notes / FAQ. And definitely read read this before you start everything. Number one, the kit comes with rail backers. And if you forget to install these before you start building the frame, you're not putting these in. So these are kind of nice. I don't think I have them handy anymore, but they are just long bars that have threaded inserts. And you insert those every spot that a rail is gonna go. And instead of needing to insert all those roll-in nuts, you just screw into one of these. So it's not critical, but it's nice to have. That being said, I probably wouldn't install the one on the X-axis if you're looking to go for speed. Technically, it would add a little bit of rigidity, like theoretically, but I think using roll-in nuts are perfectly fine. So these are optional. They do include them though. They just make it easier to build. Let's see. Oh, okay. Page 81. The palm nut is oriented so the flange extends into the part and the accented part is flush. Is that how I have it? I'm looking at the Z. No. I don't think I have it set up that way. Do I? Yes, I do. Okay, those are the side pieces. That's fine. Z carriage rear. Okay, so I have this piece right here. Technically, you should be following the notes as you're building the printer. It's one of the disconnects between an LDO kit and a regular Voron build is that you'll have to kind of scroll through, and as you get to a certain step, you have to go and find the notes for the LDO stuff. So page 143, we're using an M4 screw rather than the M3 screw when we attach our bed cable. So we do have a bed cable. That's good. The cable is found in the power cables bag, so we'll definitely install that. We are not using an end stop. And page 146, use the LDO bed connection printed part. So yeah, that is this part right here. So we're doing that instead of the specified one. And actually, I know exactly why. That's because our bed has a thermistor with a plug. So we're gonna be using one of those those breakout boards that connects in here, which will need some heat sets, and that will extend our thermistor very easily. So that's nice to have. So we'll have our mains in and out here, and I guess the protective earth cable, our bonding cable. It's not technically a grounding cable, but it's a bonding cable that will connect probably back to the frame. I don't know. Let's see. We have our power cables, miscellaneous cables, bed thermistor extension cable, frame PE cable. That's not what we want. We want the bed PE. Yeah, there it is. It's in there. So another one of the many reasons to get an LDO kit is that they have all the wiring, and you don't have to do theoretically a single crimp on this whole entire thing if you build a completely stock build. Now, I will be using my own tool head, given it is an LDO tool head, but I'll have to crimp some things, some very basic things, because I have a Jabberwocky, and my specific Jabberwocky is only the Jabberwocky kit, and I don't know if it comes... I don't think it comes with the heater, because ours doesn't come with the Thetis hot end, because I just got the kit. So it does have pretty much everything else wired, which is actually kind of nice. I didn't realize that. It has all the fans. Those are all wired. The motor is wired. And then our LEDs are wired. So the only thing we have to worry about is connecting the thermistor for our hot end. So that's not too bad. And honestly, that should probably just be included with the kit, now that I'm thinking about it. But just to be safe, if you are going to get a Jabberwocky kit, get it with the hot end, get it with everything, just to make sure you have all the right cables. And if you do, you shouldn't have to crimp a single thing on this printer, which is very cool. But there are a lot of wires because this is a 4-arm build. We are looking for a bed PE. Aha. This is not what we want. I don't actually know where that goes. This probably goes into our power supply. There's a lot here. Hold on. They're all labeled very nicely. And I think this is the frame protective earth cable. So this will attach to our frame. It's going to tell you to actually grind off a section of the anodized metal. But as long as you're attaching it somewhere that is the screw goes into the frame, you should be good. So we'll install that at a later point. And here is the bed PE. There we go. So this is what we're actually going to attach to the wait, no, this is just PE. Hold on. Frame PE. Oh, there's another one? No, I lied. Don't listen to me. I don't actually know what that one's for. Oh, maybe that's connecting our power supply. Yeah, this connects the power supply to the main breakout. That's at a later date. There we go. Here is our bed protective earth. So this cable will go all the way directly back into the main grounding distribution connector. So we go from our bed, we're going to screw this right here onto our bed as specified in the manual, and that'll go all the way back down. If you're going to ground anything on this printer, you should definitely bond the bed. If for any reason, for whatever chance, that bed becomes live, that will directly receive 120 or even 240 volts, depending on your region. So definitely ground it. Very, very highly recommended for safety. Very, very, very highly recommended. So we need that cable. That's a good one. We need... what other cables here? Okay. So you have Wagos. And I don't know if we're actually wiring back up right now, but we'll just keep that out and about so we know. Actually, I'll just put it back for now. We know which one it is. It's the only cable that's labeled correctly because, again, it's an LDO kit. Good stuff. Keep this all back in the bed for now, but we know what we're doing for later. Put this aside. But I do need to install some heat sets. I've reprinted the same part in, Polymaker's Galaxy Blue. Even though you're not going to see it, it looks better, doesn't it? Yeah, it totally looks better. So let's go ahead and throw some heat set inserts into those. Normally you don't need any, but because this is an LDO kit, we are screwing in a little mini PCB that's going to extend our thermistor, which is pretty nice. So I need our heat set inserts, which should be around here. We're going to drive a couple of those. I don't actually know if I've shown off using this stealth press on stream, or at least on one of these videos. But you essentially have your whatever your favorite soldering iron. You have the attachment for the stealth press, and you put your heat set insert right there, center over the hole. Once your soldering iron is at temp, you lower it down, and you don't want to really press, but you want to give it a gentle press, and you're just kind of waiting for everything to heat up, right? You're waiting for the heat set insert to heat up, and as it heats up, it's going to slowly press itself into the hole, and you're looking for the final depth of the heat set insert to be just below the surface usually. So that's what it's going to look like that. It is inserted just below the surface. It's not sticking up, and there's not excess filament around it. If your holes are too small for whatever reason, you'll have a bunch of excess filament. If they're too big, then you won't actually get a good heat set insert, and it might just pop out. Another note, if you're ever screwing anything into a heat set insert, do not over tighten, because these things with a little bit of extra force will just pop right out, or they'll just free spin. And that is one of the most annoying things in a 3D printer, is when you can't remove a screw because your heat set insert is spinning. Very, very annoying. So that's why it's important to print your parts very well to begin with, making sure that your hole sizes are correct, and make sure to insert your heat set inserts as good as possible. Also, make sure they go in relatively straight. It helps with assembly. So that is that part. We are going to insert some Wagos. This kit does use a lot of Wagos, which is very, very easy and nice. Makes installation very straightforward. So I have, let's see, 412. Okay, these are the ones I need. These are the 2-piece or 2-section Wagos. That comes in a little bag like this. And those insert, kind of gotta shove them in there. It's a press fit, so they will press fit in very snug. Don't be afraid to put some pressure in. Kind of get it in a little bit, and then press it in and push it all the way back the best that you can. I don't think these are actually, there we go. Press all the way to the back and then down. Come on. Is that in? Can't tell. There we go. No, it wasn't. There we go. That was a nice snap. And that is not going anywhere. Wow, that's very in there. And then for this build right here, I don't know if it's specified in the LDO part. See the wiring guide. Okay. So we're actually gonna have to go back to the wiring here, and this is a 300 wiring. There's a 250 wiring and a 300 wiring. We're gonna look at the 300 wiring. Thoughts on using pressed hex / square nuts instead of heat set inserts? I've used a couple of builds where you insert either a square nut or a regular hexagon nut, and those are fine, except they do want to come out. Like if your hole's too big, they kind of slide out, and if you put too much force into them, they have the potential to just free spin. Specifically the hexagon, the standard nuts. So I don't love them, but they are useful in situations where you don't have the depth that you need for a heat set insert. There are options. Let's see, wiring. So let's just take a look at the bed. This is stealth burner, clicky. We're not doing any of these. Aha, this is that part that we just did right here. So once again, it is best instead of being 2.5, guides into this printer, start this build by looking at the documentation and read everything, because it does vary a little bit from the stock build. So this is that little PCB I was talking about. It is just a little extension PCB, and we're going to install those with some M3x6, maybe. Yeah, M3x6s. And then we're going to attach it to our bed, which we haven't fully assembled yet, with some screws there. And that's how it's going to be wired up. So our bed connection is going to go all the way back. Our thermistor has an extension that goes back, this yellow one right here, and we're plugging our bed to the other side. And make sure to follow the wiring for the heat bed and all the other stuff correctly. It's very, very, very important. I don't think this could be too much simpler, but if you have any questions on wiring, completely stop, and go to one of the various Discords for support. You can ask anyone. They should be able to point you in the right direction. Just be very careful with that. And that's what it looks like once everything's installed. I also love how they give you what this is supposed to look like. If we go to the bottom where our electronics are, it shows you how everything is wired, how it's run. It looks very, very, very neat. One thing to note is we are doing inverted electronics. That means instead of looking at the bottom of the printer like this, we're actually going to be looking down into the printer. So every one of these components, we're essentially going to take it and flip it 180 degrees. Just flip it. It's going to be in the same spot, but it's going to be flipped. And that'll make sure that all of our wires will still reach everything, because they are cut to the appropriate sizes. You'll still want to follow this layout, but definitely keep in mind that everything is flipped upside down. And I'm not going to go through the entire wiring for this printer, but again, LGO provides all of the everything. It does not really get much better than this, besides maybe a video guide on how to assemble everything. But since our build is going to be a little bit different, I won't be following everything perfectly. We will have a different, let's see, we're going to have a different hookup here. We are running a different control board. I don't see them actually using one here, but we have a, what's it called? A Nighthawk. So even with the stock version of the Rev D kit, you're running a Nighthawk for the Toolhead board, and that will go into a little breakout board, which then plugs into USB into the Pi, and then it also uses power inlet. So that's not shown here. I wonder if that's on purpose. Yeah, this is Rev AC. Do they have a Rev D wiring? Aha, here it is, Rev D. See? Got him. So Rev D. So everything's gonna be the same for the bed. In fact, I don't know if it's any different. I don't think so. But the basement is gonna be laid out probably a little bit different. Yeah, quite a bit different. We no longer have that big breakout board, and instead we have this piece right here. This is our Nighthawk adapter board, essentially. And this is using the Leviathan. So our Leviathan is going to have a additional board. I don't know where I put it. It's handy. But we're going to have a... Here it is. The expansion board right here. So the expansion board hooks right up to the main Leviathan. And it jumpers over or something. I don't actually know how it connects yet. Yeah, it has jumpers there. So that plugs into the main Leviathan and gives us 2 additional stepper motors. Those are for our 48 volts all-wheel drive gantry, which is pretty nice. And it does give us additional thermistors and fan ports, which we don't need, but if you're running thermistors to your stepper motors, make sure they don't overheat. You can use that for that. So next to our Leviathan, we're going to have this expansion board. And I think that's the only difference for the most part. We're still going to have a Nighthawk, just instead of using the self burner, we're using a Nighthawk 36. Yeah, everything's much more simplified in this version. Much more simplified, and it's going to look like that once we're done, pretty much. That's awesome. Yeah, I'm actually pretty pleased with the wiring on this. Our Pi, Raspberry Pi, plugs directly into the Nighthawk too. So that's very nice. Yeah, this is good. Very nice. So again, if you're running a Rev D kit, make sure to follow these instructions. I am not going to give a step-by-step guide on this, but if you have any questions that I can answer, feel free to ask them. Otherwise, make sure to contact someone for support if you have any questions. Bearded Printer, thank you for the 13-month sub on Twitch. If you're not sure what subs are, you're missing out. Join Twitch. It's fun, I promise. So let's see what else we can get done for this video. So that's the oh, we also need the little board here for our thermistor. So that's going to be in one of the electronics, probably electronics 2 box with all the miscellaneous connectors. 2x2 XH splicing PCB. That sounds correct. Get that opened up. This is what I was talking about earlier. This will extend our thermistor. Thank you, TJ Magneto, for the 200 bits. That screws in just like this. There's a little cutout back here for where the soldered pins poke through. We're gonna take that. We already have our heat inserts there. We just need some 6mm screws of some sort. I don't know if I have them out. Have I used 6mm for anything? Bearded Printer, thank you for the 100 bits. Lots and lots of parts here. Remember, folks, stay organized as much as you can. Whatever your method is, you need to stay organized. Do not lose any parts. Don't lose any screws. Put everything back when you're done with it. More than ever, it's very important to keep organized. If you want to print out a organizer, like hex tray or one of my mod units, then those are pretty good. Just make sure to keep track of what parts are actually what. So don't just dump out every part without knowing what they are. We should have some screws for this. I'm trying to use the screws that are included in this kit, if I can. Makes the most sense. M3x8. I think we wanted... Yeah, they are. M3x6 button heads. Perfect. See? Around here somewhere. That's why I also recommend, if you're building one of these printers, to have a dedicated space for the entirety of the build. Plan on multiple weeks of building, right? If you're only putting in a couple hours per day, then, well, you need to have a space to keep all your stuff. You're not going to want to put everything away between sessions. So, keep that in mind. And don't let anyone touch your parts. So that's screwed in there. TG Magneto, thank you for the 100 bits as well. That's pretty good. So this is LDO specific. Just get that prepared. And the frame. So the frame is a fun one. Push all these parts aside here. The frame. We have a hole in this extrusion, and we have a threaded side on this extrusion. And we're essentially connecting it like a T. And we're using an M5x16. And if you've never seen a blind joint, this is how they work. This is why I wanted to show it. So you'd think that you would screw in the screw through the extrusion like that, right? No, you're wrong. Sorry. So what we're doing is on the end of this extrusion, we're going to screw in this screw like this. And we're going to not screw it in all the way, but we're going to leave it sticking out just a little bit, just like that. Then, on whatever side the hole is, we're going to slide this extrusion in, just like this. Now it's kind of locked in place. And using the hole on this side, we're actually going to stick our driver through and screw that screw in, just like that. That is called a blind joint. Now, before you tighten this, if you just tighten it randomly, it's not going to be centered, right? You still have a little bit of wiggle room here. There's nothing saying that it's, there's nothing centering this. You can guess, but that's not going to get you perfect. What you'll want to do is use some form of either measuring tape or ruler or even just a piece of paper. Find some way of finding the center of this. Now, I recommend a ruler. This happens to be a Voron ruler from one of the various rep events. But you want to measure it from one side right here and get a value. So let's say this is 20 centimeters. I'll measure it on this side as well, which is kind of hard, but that's actually 20 centimeters. Wow, that's perfect. That's actually perfect right there. We just happen to randomly guess. And just to verify, I can kind of put this against the edge and hold my finger against it where it's supposed to go, and then flip it around. And it feels like it might be a little off. Let's see. This is exactly 20. And yeah, this side is like 19 and some. So it needs to slide over. Let's see. Need to slide this way a little bit. So I'm going to loosen this up. And then ever so slightly slide it this way. And retighten it. I'm going to recheck. This is a little under 20. And this is exactly 20 again. So I'm going to take this and slide it the other way. Just a little bit. Yeah, play around with it. Just try your best to get it as centered as you can. Also, when you're doing your final tightening, you want to make sure that these extrusions are flush. Right now, they are not. I don't know if you can see this on camera. Probably not. Yeah, you can see it. This one right here is kind of sticking out. You want both of these to be completely flat. If you don't have a perfectly flat workbench, get yourself a 1, 2, 3 block, just like that, and tighten it on top. So loosen it and retighten it on the 1 through 3 block, pressing both of them, both the extrusions on there. That'll make sure that they are flat on that block, or any other flat piece of something. Now, if I run my finger on both sides, it's completely flat. That's what you want. Flat and square. More critical for part of the actual frame, but good to have on every single part of the printer. Remember, anything that you're a little bit off could cause potential binding. Binding causes issues. I keep being a little bit off, so let's see. It's I'm gonna call it like after this one right here. It's so minute that it doesn't actually really matter. We should be fine. Should be fine if it's off like a millimeter, but definitely take your time. This isn't a build that we have to rush, right? We have time. Just try your best to make everything as aligned as possible. And do note that even though I built a bunch of these printers, it's not like I can just screw this together in about... I did it the wrong way, did I? Shoot. I can't get this perfect every time. So I can just slide slide it this way. Hold on. One last time. I made it worse. So let's loosen this, and I will measure it, as you guys are probably screaming in the comments. I want it to be just about like right there. Give it a bit of a snug, and then I will loosen it, keep it in the same position, and retighten it on this 1, 2, 3 block. Okay. And that's perfect. All right, just under 20 on both of them. So now that we have our T, just like this, now we can install this in the printer. Or we install our... No, we put in some nuts. We have some bearings. Yeah, I think I'll do this off camera. But if you look at the guide, we insert some T-nuts here, and then we have these bearings. These are kind of fun. This allows for the bed to kind of tilt, but stay constrained. So make sure to follow these instructions very well. We're installing all of this stuff in there. And at one point, yeah, the bed has to be screwed in. You can probably do this before you put... Yeah, definitely put this mount right here, the LDO specific one, in before you put the bed in. Just makes it easier. I don't know why they put it in after the fact, but it is what it is. And then they have their example of the bed wiring. Do make sure to follow the LDO wiring, okay? Follow the LDO specific wiring, okay? And then the next part is building the tool head, which I'll probably do off of the off video. So we'll see what the next update is, but that is really all I have for you on this build. There is quite a bit left to do, but it's all very straightforward, especially the wiring. It seems like a lot, but it's very straightforward, just connecting everything together. So I'm going to do a little bit of experimenting off stream to make sure it all works, and then I'll show you guys what I did and how it worked out. If you have any questions or something I might have missed that I did on this build, feel free to ask in the comments. You can also join my Discord and ask there, but happy to hear all the feedback and comments on this build as I go through it. There's things that might change, there's things that might add, and that's the beauty of building a custom 3D printer. You can do whatever you want with it. It's your printer. Do it the way that you want it to. Remember, you're gonna have this thing for a long time, so make sure to build it as if you're gonna keep it forever. Make sure, if you didn't watch for whatever reason, a little bit late, but go back and watch the previous builds of this Trident series. Also, if you're looking for some other stuff to watch, check out my YouTube channel. I have some additional builds where I work on some other various printers, including the Stealth Changer build series, and I did a Micron as well. All very fun printers. That being said, have a good night, good morning, good evening, and goodbye. Make sure you like the video.